Today we're going to learn about a new number, and that number is e. So right here is our definition of what e is. The natural base e is an irrational number. It's defined as follows. As n approaches infinity, the number e is approximately 2.71828 and so on. So e works just like the number pi. So you're familiar with pi from geometry. Well, e is our natural base. So when we simplify expressions with e, we're going to treat the e like it's a variable. We're not going to plug in 2.7. We're going to leave e in our answer. Just like if you had pi plus 3 pi, you would write 4 pi. We don't want to multiply that out. This is exact. If you plug in 3.14, well, that's just an approximation, not an exact value. So this is our preferred. So when we simplify these, e is going to be in our answer. When we have the same base, we add our exponents. So here we can multiply our coefficients and add our exponents. So keep going. You do 3 through 6. We'll pause the video so you can try those 4 problems and then resume so you can check your answers. So for 3, I'm going to add my exponents. 2x plus 4x is 6x. Here, I need 2 to the 3rd and e to the 9th. These get multiplied, and don't leave the 2 out. So that's 8 e to the 9th. For 5, we subtract our exponents. And for 6, divide the coefficients and subtract your exponents. If I show my first step, I get a negative exponent, which means just this part of the expression moves to the denominator. Now there is a button for e on our calculators. So take out your calculator now. So when I want to calculate e to the 4th, e is right above the button that says ln near the number 4. I'm going to press second ln button and I get e with the exponent. 4, enter. And it says round to 3 decimal places. So that is 54.598. Okay, we can do e to the 1/3. .396. E to the 1.2. And 2 e to the negative 1/5. Okay, we can also graph with e as our base. So remember, e is approximately 2.7. So if we graph all of our other properties to start, so I'm going to start with my horizontal asymptote at 2. I move to the right 3. So normally we go through the point 1. Move to the, to the left 3. Now the question is it a growth function or a decay function? So let's think. The base of e is 2.7, which is more than 1, so it's a growth. And this is just a sketch, it's not exact. And actually, I'm sorry, down here, since we asked for intercepts, let's find the y-intercept. and then I can graph that. So the y-intercept is when x is 0. That's e to the third plus 2. Now I can leave this exact for when I have my y-intercept down here. But if I want to estimate that to plot the point, I'm going to say e, I know e is 2.7. So I'm going to round that in my head to 3. So 3 cubed is 27. So that's at 29. So I shouldn't cross my y-axis here when I sketch this, because I don't have a height of 29. So we'll go up this way like that. Okay, let's fill in all of our properties. Domain, x is all reals. For range, we have nothing until 2, but we're not equal to 2. That's y is greater than 2. If we're walking on our graph, we're increasing everywhere. So that's negative infinity, less than x is less than infinity. We're never decreasing. We have no maximum. We have no minimum. It is one-to-one. The original is a function, and the inverse will be a function. X-intercepts, I have to calculate that. That is when y is 0. We get negative 2 e to the x plus 3. But wait. I have an asymptote here. My graph's never going to go below it. Will my graph ever then touch the x-axis? It will not. So we actually have no x-intercepts. Or I can think here, e is 2.7. Can I raise that to any power to get a negative? Nope. Okay, for a right end behavior, as x goes to infinity, our graph is going to infinity. And for a left end behavior, as x goes to negative infinity, the y is approaching 2. And our asymptote is at y equals 2. And then last but not least, we can talk about money again with E this time. So we learned that the amount of money in an account earning compounding interest was this formula. So now, as n approaches infinity, our compound interest formula approximates continuous interest, meaning you get interest continuously as compared to before it was compounded monthly, compounded daily, compounded yearly. Now we're compounded continuously, and we use this equation, or this formula, to calculate that. So we'll pause the video so you can write down that formula. Okay, so I'm going to rewrite that here. You can remember this as short with PERT. You will not be given this formula on any assessments. That is something that you have to memorize. So if we deposit 1,000, that's our principal. Our rate is 8%. Compounding continuously means I use this formula. And 1 year is our time. So let's plug those numbers in. We always use our percent as a decimal. This is a calculator-ready expression, so for our non-calculator quiz, or test, you could, if it says leave your answer as non-calculator ready, you would leave it like this. If you have your calculator, which I'm going to take mine back out, we can type that in and actually get a value. 1,000 e the 0.08. So that's $1,083.29. Okay, we're going to try another one, number 2. You deposit $1,500 in an account that pays 7.5% annual interest, compounding continuously. What's the balance after 5 years? So again, we're going to use our continuous interest formula. Principal, rate, time. And now we have to be careful when we plug this into our calculator. Make sure you close your parenthesis on your exponent so that the calculator knows you want to multiply the rate and time before making it an exponent. We would have $2,182.49. Okay, so that is our overview of E. You are now going to work on this page in your packet.